This week on the show, we look at Lumina Desktop 1.3, the new release. We show you also how to use Plasma 5 on FreeBSD as a tutorial and explore the randomness in all its weird incarnations and more in this week's BSD Now episode. BSD Now, episode 206, To Air is UNIX, recorded on or for the 9th of August 2017. Hi, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
Now, we had a little bumpy start here, but that doesn't stop us from giving you the news this week. And the headlines, today we have Lumina Desktop version 1.3 being released, or is out now. So this is on lumina-desktop.org. And what's the news? What's new in this release?
Yes, so quite a bit is different here. Firstly, they have a new utility that's part of Lumina, the Lumina-Media Player. It's a graphical interface to Qt's Media Player class, and it also has built-in Pandora Internet radio streaming. It can play various formats like OGG, MP3, MP4, FLAC, WMV, etc. And you can also extend that further by just installing the GStreamer plugins, and then it can play other formats too. It's available in the applications utility section of the start menu-esque thing in Lumina, or by running Lumina-Media Player on the command line. They also have another new utility called Lumina-XDG-entry, which is designed to create .desktop entries and shortcuts. So normally when you install an application on a graphical UNIX desktop, it installs a .desktop file in a directory, and that makes it automatically show up in all the different desktop environments. But with this XDG entry utility, you can edit those files easily and create new ones and so on. Quite a few other changes. On the actual desktop itself, desktop folders are now integrated and can be manipulated directly on the desktop. They added a new automatic setting migration of the desktop monitor so that if you move monitors, it can do the right thing. Numerous speed and performance improvements on how icons load and how the system interacts with the desktop. The file manager got a bunch of interesting stuff. They've now fully integrated their Lumina archiver, which makes it easy to open various archive type files. A system directory tree pane is available with options to enable or disable it, which will be added later. And numerous speed improvements to the caching and loading of icons for the different version there.
Oh, good.
The Lumina text editor now has a new JSON manifest file format for syntax highlighting. Users can open the file, customize their highlighting options, and immediately see their changes without rebuilding the utility. And the text editor has built-in support for more than 10 different file formats now.
Yeah, I think they mentioned something in the BSDCan Doc Lounge about their documentation team requesting some changes so that they can make the changes easier visible with that editor.
Mm-hmm.
Cool.
They added file-wide preferences to the syntax files, like word wrap, character per line limits, etc. Because in particular, the FreeBSD documentation stuff uses, I think, 72 characters?
Mm-hmm.
76, something like that, less than 80. And so being able to set that on a per file basis makes it easier to work with, C files that need to be 80 and docbook files that need to be 72 or 76. I forget which. So they added support for that. They also added tabs with detach, drag and drop, and location customization in the view menu. A menu to show all the unsaved changes in a dialog box when you try to close it. The screenshot tool has been adjusted and improved. Adjustable warning when closing without having saved the image. A bunch of changes to the archiver. And I think there's one in here that was done for me that's not listed. Was the Lumina PDF viewer, specifically for doing presentation slides ahead of and behind where you currently are, so that the slide switching is faster.
Okay. That's also something people might want to have and use.
Yep.
Oh, and Slackware is also supported, I see, in the more detailed general improvements. So Lumina is not just a BSD distribution, or desktop, it's pretty much universally available in other systems as well.
Yes. Well, it's designed specifically for FreeBSD in order to make life, or to stop having the problems of constantly trying to keep up with whatever Linux decides to do for their desktop environments. It also means that Lumina works very well on Linux because it contains all the portable bits and it doesn't depend on a lot of external stuff.
Yeah, that's nice.
On FreeBSD, they've split Lumina up into 12 different parts. So there's Lumina, which is a metaport that includes everything. Lumina Core, which is just the desktop and the themes and the various bits you need. The core utilities, which includes like Lumina Config, Lumina Xconfig, Lumina Search, or whatever. But then the archiver, calculator, file info, file manager, media player, notifier, screenshot, text editor, and the XCG entry utilities are available as separate ports so that you can install just, if you like the file manager but don't want the whole Lumina, you can install the file manager and use it under GNOME or KDE or whatever.
Okay. Yeah, this is something people should check out, definitely. This is a nice release, and I think they're also planning new stuff already for the next release. There's constant development going on and improvement and additions to new utilities on the desktop. Next up is FreeBSD 11.0 and the Plasma 5 how-to. So this one is a blog post, and I think we had this a couple of weeks ago where we had some experimental from the Area 51 part, and this is now a more complete how-to as far as I can see.
Yeah, so basically the tutorial is fairly straightforward. It's install FreeBSD, get X up and running, switch your package set over to the Area 51 packages, and install KDE, and then you'll have all of this. So yeah, a step-by-step guide on getting a machine that has FreeBSD 11 on it and getting X running, and installing KDE Plasma 5 Desktop and KDE applications. It's the latest thing, except that, 11-stable is in the middle of the pack on what's supported, but the KDE bits are fresh. So it says the FreeBSD version you're using isn't all that important, except that packages are readily available for 11 stable and not for 10 stable. So the first thing to do is obviously download and install FreeBSD 11, 11.0 or 11.1 should work.
While you're there.
Then once you've booted off the CD or mem stick, you can use the installer and install a system. Set your time zone, your root password, all that general stuff from an install. Pretty straightforward. Once you're done, log in as root, run port snap, fetch, extract in order to get the latest ports, and FreeBSD update, fetch, install to get any security patches. Then you can bootstrap package, install git, bash, gmake, cmake, packageconf, get text and bin utils. And then you can install xorg and twm. So you get a basic X environment going.
Very basic.
Yep. And then once all that's good, you'll have a basic 1980s looking X going. As you can see.
It's a start.
Anyway. Now what you want to do is take a snapshot of your ZFS file system at that point, so that if something goes wrong, you can always go back. Now you want to swap out the default FreeBSD package repository and switch to the KDE FreeBSD community one, also known as Area 51. So we make the directory user local etc packages repos, and in it we create two files. First, a freebsd.conf that disables the FreeBSD repo, and then an area51.conf that provides the URL to where the Community 11.0 AMD64 KDE packages are. Then we do package update to make it download the repo metadata, and then package install of the Plasma 5-Plasma-Desktop, and then we can set up webcamd so it has access to all of our devices. Then configure the xinit RC so that it will start up KDE. And then next time you run startx, you'll start getting the Plasma 5 desktop.
Yep, in all its beauty.
So then just package install KDE, and that'll bring in the rest of KDE on top of the Plasma 5 desktop, and you'll get all the applications and stuff, and you end up with a nice machine.
Graphical desktop and all. Yeah, and some eye candy and the usual KDE applications that you are probably used to. Yeah, this is pretty straightforward.
Yeah, my only criticism, this is just in general of tutorials, is what I really like is to see people stop doing this. Echo, webcamd_enable equals yes, append to etcrc.conf. sysrc is in every supported version of FreeBSD. And you just do sysrc webcamd_enable equals yes, and it automatically puts it in rc.conf. If you need to put it in loader.conf, you just -f, boot/loader.conf, and it'll put it there. But it will do syntax checking and make sure that you're never going to screw it up. Especially when you want to deal with the quotes and stuff. The tutorial we covered last week had, a bunch of backslashes escaping the quote marks and so on. And it's like, that's so easy to screw up. Whereas sysrc makes sure, because sysrc is written in shell script and it parses the file, it makes sure it never writes something that's not going to work. Because, a missing quote mark in your rc.conf is the easiest way to make your system not boot. It's not that hard to fix, but as a new user, it's really daunting to mount the read-only file system, read-write, and then, maybe use a text editor you're not familiar with to try to fix that file. It can be a lot of unfun.
Yeah, we need to do a sweep of the handbook and the documentation and FreeBSD in general to look for those echo occurrences where it makes sense to replace it with sysrc.
And I'd love to see tutorials out on the internet updated as well.
Yeah, but that might take some more time.
Yes.
Yeah, but this one is straightforward, and people will be happy to try out the Plasma 5 desktop and run it on their FreeBSD system.
Yes, and definitely give that team feedback, because we hope to someday have this in mainline FreeBSD.
Yeah, that's why we have testing snapshots and all these things for people to try out and report back. Okay, speaking of environments, our next story is about...
First, we have our sponsor, UNIX Systems. So Intel's come out with this new line of, the Xeon scalable processors, and they've changed the name of everything. Now there's like the Xeon Bronze, Silver, Gold, and Platinum, and all these different things. And it's like, I don't know what's what anymore.
That can be a bit confusing.
The people at UNIX Systems, they know all of these and which one is the right one for what you're trying to do. So you just get in touch with them, explain what it is you need your new system to do, what minimum level of performance you really need, and they will help you pick out the right processor, the right RAM, the right type of SSDs, the right spinning disks, the right disk controllers and HBAs, and build a system that's uniquely suited to do the job you need it to do.
Yep, whether it's a big server or a small system like a FreeNAS Mini for your home use or office use, they have everything that you might want to have. And if you don't know exactly, then just call them and ask, and you will have a nice person on the phone where it's not the primary goal to sell you stuff, but solve your problem. You tell them what you want to do with your server, and they will tell you what components you might need and how they work together, or what other components are not so good, and they will build you a system that's exactly to your use case.
Yeah, so head over to ixsystems.com/BSD Now and get in touch with them. They will definitely help you out, and they have the entire line of Xeons, whether you want slightly older ones or the latest scalable ones, and they know which one it is you need to do what you want to do.
Okay, now it's time for our next story, which is a full FreeBSD server on a Raspberry Pi. So there's a big disclaimer at the beginning. The Raspberry Pi is such a great device. You can do a really huge amount of fun things with this little board. The goal of this paper or this blog post is to show how you can build a full personal server on your Raspberry Pi using FreeBSD and its packages. And it starts with a big, overview of 10 points where you can jump into each individual section. It starts with pretty much how you get started with FreeBSD to get it installed, and then how to configure FreeBSD. Then next up is install and configure sudo on the little device, which is relatively straightforward. Then it starts getting interesting because then you configure the Wi-Fi with a static IP and IPv4 or IPv6 address, whatever you want to use or have available. Then on point 5, we have install and start a packet filter. So they are using PF here to make a small protected system that's filtering on specific ports or blocking packets that shouldn't enter your system. Number 6 is configure and install Nginx with Let's Encrypt, so SSL, PHP, and MySQL on that small little box. So it's only the size of roughly a credit card, and that can pack a lot of stuff and run systems just as well as a big server. Number 7 is install and configure OpenSMTPD and SpamD. So we had a couple of weeks before we had a similar tutorial, and this one is relatively similar. So you can also use your little Pi as a mail server and spam filter. Number 8 has the install and configure net data with Nginx to monitor your system. So you get nice continuously updated graphs that show you how your system is doing, what kind of load it's doing, and other things you might be interested in. Number 9 is avoid OS detection. So last week we had a section about how to avoid being detected with Nmap and other sniffing tools, and this one is pretty much, it's just a sysctl you can set, but it's better than nothing.
Yes,
and there's also
just changes things so that it's harder to fingerprint the Raspberry Pi and tell which OS is running.
Yeah. And there's also a need help section. So for people who want to, so there's a little chat room there, and people can access the FreeBSD chat room. Is that the one? Oh, well, people can get into that one and ask questions if they run into problems or want to run certain other software and they're not sure whether the Pi can handle that. But the Pi is a pretty powerful board and should be able to do most of the normal things people want to run for their home use just as well. Do you have any Pis, Alan?
Yep, I have a Raspberry Pi 1, like a Raspberry Pi B and a Raspberry Pi 2. I've tried to make video streaming appliances with them before, but the video you pull in off the camera is about 40 megabits, and you only want to send about 1 to the internet, and trying to transcode it down was too heavy on the device, and a little too heavy on even just the USB bus, honestly. There apparently are some other ways to drop the quality of video without using as much CPU, if you just want to lose quality and not everything else, but I haven't looked into it that much since.
Yeah,
I know we had quite a bit of fun when we everybody bought Raspberry Pis to BSDCAN, and we were playing with them in the lounge, hooking them up to the TVs and so on, and seeing what we could do with them. But
yeah.
I've been a little more interested in the Onion Omega devices I have. I have one in reach at the moment. Turning them into tiny temperature probes to put them in my server room and around the rack and monitor temperatures and so on.
Yeah, that's a good use case. I also want to monitor the the temperature in the office and stuff like that. And for that, I figured the Raspberry Pi Zero is best suited or small enough to do just that.
The nice thing about the Omega is it's designed to have these expansion blades that go into it, into the GPIO ports. And it's got support for like 120 volt relays. So you can actually use it to turn devices on and off, like actually electrical devices on and off.
Cool.
I've looked at doing that to be able to control the air conditioning, maybe.
Yeah, small home appliance things could also be a little bit of a home project or a weekend project. And if you're doing great stuff and interesting, cool stuff with Raspberry Pi and BSD, any BSD, send it to us in a small email or a blog post that you found at feedback@bsdnow.tv, and we'll cover it in a future show.
Yeah, there was really interesting ones we've seen. We saw a garden watering system based on FreeBSD and BeagleBone Black, and robots based on FreeBSD. There was at Asia BSDCon, there was a tank that was controlled by a web browser via FreeBSD. It was very
yeah.
I think you can follow that one on Twitter. I think it's FreeBSD Tank on Twitter. And it's a little remote radio-controlled tank. It's really cool.
Yeah, and people can find a lot of these building tools on GitHub and other code-sharing utilities and use that and improve that and make their own devices. Time for our news roundup this week. The first item in that section is HardenedBSD now has OpenNTPD in base. Yep. So this is a small item.
Over the past few months, Bernard Spill has been working hard to import OpenNTPD 6.0 patch 1 into the HardenedBSD base system. Starting with 12 current, HardenedBSD will ship with OpenNTPD by default. Just like LibreSSL and base, HardenedBSD users will have the choice of building either the NTP daemons. If you want to switch back to the regular NTPD, you have to set without OpenNTPD and with NTPD into your source.conf and rebuild. Bernard will continue maintaining LibreSSL and OpenNTPD in the HardenedBSD base. If you're doing a source upgrade, after you install the new world, you'll need to run merge master or etc update, and then use sysrc to disable the old NTPD and enable the new one. If you do a binary update using the HBSD update tool, you just need to do the third and fourth step there of switching which daemon gets started at boot.
Oh, that's pretty straightforward and easy to do. So people can do that and have all the time accurate clocks and a secure way to sync their clocks. Good stuff. Next up is a little article, or not so little, on Network World by Sarah Henry Stoker called, or Stalker more? Yeah, more like Stalker. UNIX, how random is random? And it starts with an overview of what actually randomness is on the Unix. So it starts with, on Unix systems, random numbers are generated in a number of ways, and random data can serve many purposes, from simple commands to fairly complex processes. The question, how random is worth asking. And the next highlight is, so there are a couple of headlines here. Easy random numbers. If all you need is a casual list of random numbers, the random variable is an easy choice. Type echo $random and you'll get a number between 0 and 32,767, the largest number that 2 bytes can hold.
Yeah, except that's not a Unix thing. That only exists in Bash. So that only works in Bash. If you try it in SH or CSH or TCSH or ZSH or KSH, it's probably not going to work.
Yeah, that's an unset variable there, or it doesn't return anything.
Exactly. And, that's not a very random number. I'm not sure what you would want to use it for, except for maybe, like, shuffling the order of some output or something.
Yeah, it's pseudo-random and not very accurate seeding and stuff.
Not very random at all, but easy to access, I suppose, if you need something.
Yeah. Further down, there is a section about more complex random data. For more serious requirements for random data, such as its use in encryption, more truly random data comes into play. The /dev/random and dev/urandom files get beyond the predictability of programming by making use of environmental noise gathered from device drivers and other system sources and stored it in an entropy pool. Yep, that's the one that the crypto folks are talking about all the time, and making sure that there's enough entropy in there to not predict anything or the next number.
Yep, that's one of the talks at VBSDCon is going to be about the way random works on FreeBSD. So if you're interested in that, you should definitely pay attention to that one.
Mm-hmm. And there's a more detailed section about examining the entropy, so how you can access those entropy sources and look at them and what kind of numbers they currently store or have available for you. Then there's a little comparison between randomness versus entropy and how you can generate files with random data in it so that you have just random numbers, totally random in a file, which might be useful for some applications. And it closes with what other sources there are to generate random numbers. So it's a fairly good overview of random numbers in general on UNIX and how to generate them.
Yep, so they show, grabbing the first 1 gig of data from dev/urandom and putting it in a file, and then inspecting it with a hex dump and taking a look at it.
Yeah, I remember one time a student in my class asked, well, you FreeBSD folks only have a dev/random and we Linux folks have a dev/urandom. And I was like, well, look at this. There's a symlink from dev/random to dev/urandom. So it's pretty much
the other way around, but yeah.
Or the other way, yeah.
on Linux, the way their random number generator works, my understanding is it can actually run out of entropy. Meaning that if you try to read too much data from dev/random on Linux, it'll block until it comes up with more random data. Whereas if you use dev/urandom, it's slightly lower quality random, but it's a more infinite pool. So if you don't need very strong random, you can just use that. On FreeBSD, we use Bruce Schneier's Fortuna, or
yeah.
The later of the two of his random number generator algorithms. And so the randomness is in a pool that doesn't run out. Basically, it goes through a hashing system and is constantly being refreshed such that it can't run out. So we only have the one device because we don't need the distinction between the two, but you can use either.
Yeah.
So yes,
yeah, entropy
on Linux, dev/urandom is unblocking. On FreeBSD, both are.
Right.
And yes, the chat room points out it's Yarrow is the older one, Fortuna is the newer one, and Fortuna is what we're using on all the newer versions. I don't know if 10.3 might still be Yarrow. I forget. There's a way to check for the sysctl on like kern.random or something like that tells you which algorithm it's using.
Yeah, it's in there. And to make a bad joke, entropy ain't what it used to be. Okay, moving on. Moving on to our DigitalOcean, which is the second sponsor in our episode this week, which gives you a nice way of starting your droplets, which is a virtual machine in the cloud. Relatively simple and easy.
Yeah, in particular, we talk about BSD a lot, and a lot of people who are watching this have not had that much experience with it. If you'd like to have a test machine that's easy to throw away, but is fast and, permanent and you can access it from anywhere, not just, a VM on your laptop, for $5 a month, the DigitalOcean droplet running FreeBSD is a great way to get to play with FreeBSD. And if you break it, you can just throw it away, but it also has snapshots so you can revert it back and all that fun stuff. But DigitalOcean's got more than just droplets now, right? In addition to the droplets that you get, you can also have storage where you can attach block storage that's SSD backed, and you can just select how many gigabytes of space you need between 1 gigabyte and 16 terabytes. Get exactly the amount of space you need, attach it to your droplet and use it. They also have a separate object storage thing now, which is interesting. They have lots of networking options, including load balancers, floating IP addresses, and cloud firewalls. And then they have all the locations you could ever want as well. You can put your droplet in San Francisco, Toronto, New York, London, Amsterdam, Frankfurt, Bangalore, or Singapore. I think I got all of them. That sounds right.
The most important ones, yeah. It's pretty much around the world.
But other things that I find very useful, team accounts. At Scale Engine, we use DigitalOcean for scaling up when we need it. And that means that there are 4 people that need to be able to log in and do stuff to our droplets. Rather than having to share passwords, we can have 4 separate people. It also makes it easy for me to keep one login, but lets me do my personal account, a group account for another thing, and my company account, all with one login, and I can just pick which set of droplets I want to work on and do it. It's great. They have command line tools and an API, or rather an API and command line tools to let you use the API, but it means you don't even have to use their very nice web interface if you want to spin up droplets. In particular, if you need to spin up, 30 of them, using the command line of the API is much easier. They have a great 4.9 SLA, 24/7 tech support, all the things you could need.
Okay, yep. There's a lot of stuff you can also do programmatically if your droplets start growing like weeds. If you have more and more, you want to programmatically control them via curl, Ruby, Go, or docstl. So there's a couple of APIs there for you to control.
There's a PHP one as well. There's lots of different ones. And if the default layout of droplets isn't to your liking, for $10, this one isn't the right size. They also have high CPU, which gives you about 4 times as much CPU performance than the lower end ones, or high memory droplets. If you don't need as much CPU, but you need more RAM, they can do that.
Yep. So it's all a good package, and people should try it out more.
Moving on, we have a Dragonfly story. So over on the Dragonfly mailing lists, they have a new post that starts off, I would like to introduce a few ideas about the new firmware subsystem. I assume that it should not require adding a new system tool or modifying the boot process. Simplification is the first thing. It would be good to remove the parent-child relationship and corresponding functionality. It would significantly simplify firmware handling. It's only practical use is when there are multiple images for one loadable kernel module. The module can be unloaded, then all of its children are not in use. Usage of the children images is tracked through the counter in the parent image. If images will not be placed inside loadable kernel modules, the parent-child mechanism won't have any practical meaning anyway. It says, I think currently the mechanism is not used anywhere in the Dragonfly system, and if it was, it would be easily replaced by putting every child image in its own module without modifying the drivers. So there are 2 use cases according to those who provide firmware images to the system. The first is developers of Dragonfly BSD. They can modify and rebuild the system. And the other is third parties. They should not be required to modify and rebuild the system because they just want to give firmware images for their customers to use on unmodified systems. All firmware images need to have some information attached, at least if a special license agreement is required, then you will need to be able to check that the user has accepted that license and so on, and that should be stored persistently. The question is where to save the information for non-built-in images. Various solutions are proposed that meet some but not all of the mentioned requirements, along with the pros and cons of their different options.
Yeah, it's spanning a discussion there, so it's an interesting concept to do this in user land. Because otherwise,
it closes with, there would be 2 firmware sources, the kernel and the file system. In case of the same image names, users would have the choice of setting a kernel environment variable, and then firmware from which source has higher priority would be provided when they load it. So this would allow built-in firmwares to be overridden by, say, newer firmwares that exist on the file system.
Okay.
So as we see devices move more and more to this model where instead of the firmware being built into the device on embedded storage in the device, that it's cheaper to have the OS load the firmware at boot every time. I think some of these solutions are going to become more and more of a thing.
Well, the kernel folks might argue that the protective rings of the kernel might solve some of these problems, but it's always a back and forth and a trade-off between where to put it.
And it comes down to most of the time on Unix systems nowadays, you're not actually having multiple users. The person running as a regular user also has the ability to perform actions as root and so on. There's not that often where you're going to have a laptop that actually has multiple users, and some of them are completely unprivileged. And so depending on the model, it doesn't always make sense.
But it's interesting, and we'll have to see what the Dragonfly folks think of that and probably implement some of those. It'll be interesting to watch.
We provided a link, and it has a whole thread, and there's some interaction going on there.
Yeah, people who want to chime in can still do that, or think about whether this is useful for other BSDs. So we might have maybe a conference talk in the future about this. Could be a thing.
So next up, we have OpenBSD changes of note. For some reason, Ted has decided to stick with his randomly large numbers. So this is number 625.
We're used to it by now.
Continued with some of the cleanup and improvements of the depends step of the building process. Lots of little things to support Lex and Yak and so on. Interestingly, they have Intel Optane, which is their accelerated NVMe persistent memory type thing. Apparently, some of those parts have leaked out into the wild, and so they have some driver fixes to support those. They've added support for pattern substitution in variables in KSH using a common syntax borrowed from KSH93. And then it was reverted, so don't actually have that one. They deprecated the fgetln, which basically read one line from a file descriptor. They don't use that one anymore. Add a detection of missing xset in syspatch. So the OpenBSD package manager and syspatch and a couple other things have long assumed that you install the X package set when you do an OpenBSD install. And a lot of people, especially on their first time where they don't know better, are like, well, maybe I don't need X. But if you don't install the X set, then you basically can't use the binary packages that come with OpenBSD. And apparently you couldn't use syspatch, but now they've added detection, and I don't know if that makes syspatch behave or if it just tells you that you can't do it. But they've got further refinements to the Intel DRM code, including better backlight support. So they're continuing to advance on the graphics there. They've added a special version of SlackD, which is the stateless auto configuration for IPv6.
Good,
they say after much wailing and gnashing of teeth, they've fixed the stir to L to parse strings like 0x ridiculous and do the right thing. They fixed malloc and zero-sized allocations when using stack canaries. So there was an issue there if you asked to malloc 0 bytes of memory, the canaries would cause problems there. They've also added the ability to pause and unpause VMs with VMD, their virtualization system. They've removed the listen secure syntax from the smtpd.conf. It's been broken for a couple of months and no one was complaining, so they just got rid of it.
Oh, yes.
They've removed sending of router solicitation and processing of router advertisements from the kernel, so I guess it's probably in userland now. the sysctl that controls what happens when you close the lid on your laptop has been changed from lid suspend to lid action, since the action you choose might be something other than suspend, so it made sense to change the name. They fixed the Fortune utility to filter out unprintable characters. They converted all the Fortune files to UTF-8 instead of the archaic overprinting they were doing before. Fortunes with unprintable words may still be obtained using the -O option. They've added some quirks to the IDE and ATA code to prevent drives from attaching twice in Hyper-V, where the same device would show up at 2 different times and cause problems. They've added the VMCTL send and receive, which is the basis of a non-live migration for VMs.
Yeah, we covered that in an earlier show.
They've updated the version of Xterm to 330. Cleaned up some stuff in DH client, which will now not deliberately attempt to interfere with other operations on the same interface. Updated the version of libxpat to 2.2.2 to fix a null parser dereference that would crash things. And they note that Ilya von Sprundel fixed a whole bunch of kernel bugs, including information leaks, erroneous signal handling, and some unbounded mallet calls that would possibly take too much memory. And he says, lions, tigers, and bears, try to fix them all.
That's
we
a
thank
good
Ted
summary.
for providing us a nice, succinct list of what's been happening in OpenBSD lately.
Yep, that's always good to get updates in between releases to see what people can be excited about when the next major release comes out.
Yep. Or, in the case of some of these, it's like knowing that the change is coming, or, it's like, well, this has been broken in head for a while and nobody complained, so we decided to remove it. Now's the time for anybody that does depend on that to be able to speak up before the next release and it, becomes removed permanently.
Yep. So check those out and report anything you might find to the OpenBSD folks. So now it's time for our BSD bits this week, starting with the air description of the file system hierarchy. So there's a web page here that describes where is the conventional place to set up my program, backup, etc. in the UNIX file system.
Yeah, so they've asked, they asked themselves this question several times. When installing a Git server, the documentation advises you to put it in /srv/git. It's like, well, that directory doesn't even exist. That seems like a weird place to put it. Or, if you install Boost, the headers on Arch Linux go under user include boost. And, temporary files go under /tmp. And Docker images have a place where they belong, and so on. And so they say, after reading the fine manual, there's a dedicated man page that answers that question. So man hire, which is short for hierarchy. And you will note that different operating systems will have different layouts. For instance, Linux has one and FreeBSD has another. So if we look at the FreeBSD one, we can see that / is the root directory, and then there's /bin for user utilities fundamental to both single user and multi-user environments. So single user mode and multi-user mode. /boot is where those files go, but there's a defaults directory which has the default loader.conf and so on. And there's a directory for firmware, one for the kernel, one for modules, one for information about ZFS, etc. There's a /cd-rom directory, which is the mount point for the CD drive. The /compat directory, which is normally just a symlink to user compat, but it's where the Linux compatibility layer stuff will get installed, as well as other compatibility layers, although I don't know that there's any left anymore. /dev is its special thing, and devfd is the file descriptor file system. Then under etc, each of its subdirectories are defined. There's etc ssh, etc ssl, etc rc.d, periodic, mail, etc., and all the stuff that's in there. There's /lib, which are libraries that are required by programs in bin and sbin, which again targets single user mode. And then you have libexec, which is critical system utilities needed by other binaries but are not meant to be run directly by the user. And then you have /media, which is a convenient place to mount your USB drive and so on. The /mnt directory, which is an empty directory commonly used as a temporary mount point. There's /net, which normally doesn't exist but can be used by the AutoFS stuff to mount NFS shares and so on. /proc, although not enabled by default since FreeBSD 4, you can still mount procfs and have a /proc if you want it. A special one not that many people know about is /rescue. In rescue, there is basically one big statically linked binary, but it's hard linked to a bunch of different names. So if you try to copy that directory, it will suddenly take a lot more space than it was before. But this provides a standalone version of all the tools in there so that they don't depend on anything else. So if your system gets broken in some way, because say the /lib directory gets screwed up, the rescue binaries will provide you, all the basic utilities you might need to get the system working again.
Yeah. And BSDs in general are relatively well ordered, and you can sit in front of any of the BSDs and find the right files in the directories where they're supposed to be and where you expect them. And on Linux, it required a couple of file system hierarchy standards to make it all work, and the distros didn't all conform to it, and there's a whole mess, and it's difficult to find out where stuff goes.
Yeah.
Not on BSDs.
The biggest one that people coming from Linux will find different on BSD is /usr/local, which is meant to be where anything that's not part of the operating system gets installed. And this, by default, is where all ports and packages get installed. So if you install an application that's not shipped as part of FreeBSD, it will basically be based in user local. So its configuration file will end up in user local etc whatever.conf or in a subdirectory named after the application.
Yeah, that's important. If you need to look at config files, then you need to know whether it's a config file from the actual system, which goes in /etc, and if it's from a port, then it's on the user local. Well ordered. Okay, enough for that. Let's look at the next section in our BSD bits here. This is SSH lockout and your logs on the Dragonfly BSD list. So this is from Matthew Dillon. And apparently SSH lockout is also lockout on Mac's authentication attempts. So there's an addition here. So there's a couple of, if you do a couple of authentication attempts and they are wrong, then the logs are not filled proper or not filled too much with them as far as I can see.
This is a tool that blocks people that have tried to SSH in too many times and failing. It was only matching on certain messages in the log, and they found an additional one and made it lock you out after too many attempts of that type so that somebody wouldn't do just that type and keep failing and never actually get blocked.
Ah, I see. That's where it's coming from.
But yes, it's interesting to see them have their own SSH lockout tool. I've not looked at that one before. Now that we have BlackListD integrated into SSH, and it's kind of common between NetBSD and FreeBSD, it's hoping to see that spread out and be kind of common everywhere.
Well, yeah, it's basically blocking the brute force attempts from the SSH port.
And so this change is adding an extra type of brute force to the list of what's blocked.
Okay, good to know. Oh, yes. Yeah.
Next,
cool.
We have an update to the ports tree. Our friend Modi has added a newer version of NetData. This version includes build fixes to make it work properly on FreeBSD 12. But more importantly, it adds support for monitoring ZFS on both Linux and FreeBSD. So you can get nice fancy graphs and monitoring of ZFS. They've also added support for Elasticsearch, RabbitMQ, and Go applications via the XFAR thing. Added support for IPFW on FreeBSD 11 and later, Samba, Squid logs with the weblog plugin, and a bunch more. And this made it fast and offers a full-featured StatsD server, and it's the only one to include automatic visualizations. Sounds like a very interesting tool.
Yeah, it's nice to look at, or just have it on a secondary screen running in the background and displaying these nice graphs. And when people come into your office, they're like, "Oh, wow, there's some cool graphs there," and it's an eye catcher. And also useful if you are looking for certain problems that might come up in production or in your systems.
Yes. So next we have we're a little late to getting to this one, but Ted UNIX has read a number of books about computer programming and so on, and has decided to reread a bunch of them all at once and provide a rolling book review. So he'll read a chapter or two from each book at a time, and then write a review of that block of chapters all together for all 5 books at once. So he's rereading Coders at Work, which is a set of interviews with people who write code for a living. Also Founders at Work, which is what the previous book was based on, but it's interviewing founders of companies that have been successful in the past. The Mythical Man Month, which is a book about how if your software project is a month behind schedule, adding more programmers will only make it more behind schedule.
Yeah, that's classic computer science, software engineering lecture.
Just adding more people to the project isn't necessarily going to make things go faster. As well, he's got The Pragmatic Programmer and Code, the Hidden Language of Computer Hardware and Software. Mm-hmm. So on his blog, if you look at the book reviews tag, you can see all of the reviews he's done. But currently he was on chapter 5 when we found it in his blog. So although a couple of the books, there's more chapters or they're shorter, so he's doing 2 chapters at a time. But looking at Coders at Work, he says, as with the previous interviews, it generally most of the people were kind of against Java. But this interview is with Joshua Bloch, who's the Java architect at Google, and he was obviously pretty happy with Java. He also likes the design patterns book in stark contrast to some of the previous subjects of the interviews. And he talks a bit about the differences in Java and how Google was replacing some C++ code with Java to try to get better concurrency stuff, and how a lot of what people were talking about back then when this interview was written really applies to like Go and Rust today, and but with a different approach. He talks a bit about that. Then for the Founders book, the interviews were with Tim Brady, who is one of the first employees at Yahoo, and talks about how Yahoo had a good business model in the beginning of doing something useful that they wanted and making it available to other people. But eventually, Yahoo ignored full text search and focused on their directory. And that worked very well up until Google actually solved full text search and made it more useful than a directory. And also an interview with Mike Lizardis, the founder of Research in Motion, the company behind BlackBerry. He says he foresaw the rising importance of wireless data and mobile email and made the BlackBerry, which dominated the market at the time, and made sure to, avoid going after fads and keeping the product simple and being that, if people learn how to use a BlackBerry once, the BlackBerry is going to stay the same forever. And I can definitely see how that appealed to a lot of people that were especially kind of new with the technology when email was quite new. They learn it once and it'll just keep being the same, which worked quite well up until, we got to the point of having really good touchscreens and using your phone for more than just sending and receiving text messages and emails.
Yeah. Yeah, it was a different time, but it's actually the knowledge that these founders have acquired by doing these companies and learning all these things are good, that entrepreneurs nowadays can get some inspiration from them and maybe avoid some mistakes they made. Yeah, so check out Ted UNIX's blog about these literature
couple more books left
suggestions.
Here. From the Mythical Man Month, talk a little bit about second system syndrome, being like, after somebody's designed the first system, when they design the second one, they want to get in all the features they had to cut from the first one. So, if you get the people that built X Y, and Z, then they're going to want to build their successor system XYZ, which combines and unites the disparate systems. But everybody has their favorite feature that get cut, and it's essential to add that to the next version, and so on. And Ted wonders if maybe having people have at least made X2, Y2, and Z2 first before they try to combine them might actually go better.
Yeah, and some of these...
for the pragmatic programmer, he learning about learning to use the shell instead of clicking in the GUI. And he says, I disagree, but there's some cherry picking of the examples in there, so he's a little critical of the book. But talks a bit about the power of plain text and how easy it is to work with. Not just source code, but configuration files, data files, etc. Lowest common denominator nature means you can always work with it no matter what. And chapter 17 is use source control. Ted says, can't disagree with this at all, but the few remaining cavemen who don't yet use source control probably aren't going to start anytime soon, and that's their problem.
Yeah. That sums it up.
For code, the hidden languages of computer hardware and software, actually has an interesting example here. We're looking at a little bit about bits and bit by bit and so on. So Paul Revere had 2 lanterns or bits to convey information about the British invasion. 00, both lanterns off, was no action. 01 meant they were coming by land, and 11 meant they were coming by sea. So that leaves, what about 10? That was also for land, is because it can be hard to see an unlit lantern at a distance at night. So you don't know if it was 01 or 10, so they had to make that mean the same thing.
Well, that's
and he talks a little bit about how that can apply to barcodes when scanning. Barcodes beginning and end are set specific values so that the reader can tell if it's reading the barcode backwards and flip it before it reads it, and so on.
Cool. That's some nice stories in there.
His little summary at the end of chapter 5 of all these books was, from Yahoo to Research in Motion to OS 360, a lot of companies invested in obsolete technology, which is classic disruption, where something that didn't work yet gets better and eventually replaces the dominant technology. So yes, do we include Java in that group?
Ooh.
But it's been very interesting to see a lot of these concepts like capabilities, virtualization, containers, etc., that came up in the 70s and 80s and 90s and so on, suddenly making a resurgence now that we have the right bits to actually make them make sense, right? Like support for hardware virtualization on the processor has made virtualization a lot less costly, and suddenly we're using it everywhere. Or capabilities, suddenly we have enough stuff in the computer that we can actually dedicate bits to that, and so on.
Or just build on it.
Interesting to wonder about what old idea that didn't work is going to be the next new idea.
Yeah, it's interesting to watch back the history of how computing started and how it evolved into the things that we use now and the way we're using it now. It's definitely interesting. And the last bit in our BSD bit section is pfSense 2.3.4 patch level 1 release is now available. So that's on netgate.com. And what's news in there? This is a maintenance and errata patch release and available by running an update from an existing installation and does not have a standalone installer to download. It has a couple of security fixes in pfSense in there, and the underlying software such as OpenVPNs and other bug fixes linked in the blog post on netgate.com. And of course, most of pfSense software is open source, and they produce nice little boards that they often, or most of the conferences in the previous years, donate to the FreeBSD Foundation to raffle off. So these are always appreciated items, and people are always happy to win them.
Yep. So a good list of fixes in here, including fixes to captive portal, dynamic DNS, the virtual IP addresses with CARP, fixes to the DNS center stuff, the DHCP v6 prefix delegation fixes, DHCP, and a bunch of other fixes.
Mm-hmm. Yeah, so people should get that and feel more secure with those patches applied. Speaking of security, have you ever used tar? And if you have, then you should probably think about using it to do your whole backups, because there's a tool or an online service called tarsnap.com, which is sponsoring our feedback and question section for this week. Tarsnap is the online backup for truly paranoid people. And if you ever had to use a backup, and of course, not only the backup, but also a secure backup, because you're the only person holding the key to it and no one else, then you should take a close look at Tarsnap, because there might be a day where you need not only the backup, but also the restore. And then you want to make sure that no one else has tampered with or read your data that you have backed up into the cloud. And that's what Tarsnap provides. The infrastructure is there. You just use Tarsnap, like the tar utility you're going to know and love already. And there are a couple of clients for Tarsnap for different operating systems, the Linuxes of this world, the BSDs, and macOS 10 as well. And also Windows subsystem for Linux is also supported, so there should be no excuse for anyone using any of those operating systems mentioned not to use Tarsnap and take a closer look at what they have to offer.
Yep, it's the only backup utility that you can be sure is going to deduplicate, compress, and encrypt your data on your computer with your key, and make sure that your key never leaves your computer. It's the only way you can be guaranteed that no one else can read your data, is if you're the only person with the key. And the only way to make sure that's actually happening is to use a client where you can read the source code. And Tarsnap is the only one of those I know of. Plus, they have a nice bug bounty, so if you do find a problem while you happen to be reading the source code, do let them know about it and get paid.
Yeah, and everyone benefits at the end, because as unlikely as it's going to be, when there are errors, then you get a little reward about it, and then
not that little,
everyone else.
Pretty big.
Oh yeah, yeah, depending on the impact or the size of the bug, I guess. And then everyone, once that bug is fixed, then everyone is even more secure than they already are.
Yeah, a bug that causes data corruption or loss, or a bug which allows the Tarsnap service to decrypt a Tarsnap user's data, is a $500 bounty.
Ooh, if that's not an incentive, I don't know what is.
But even cosmetic errors like typos, $1 each.
Well, for starters. Yes. So check out tarsnap.com and tell them we sent you. Okay, feedback and questions for this week. Start with Ben and a thank you note. He writes, "Hello both. I listened with great interest about Adam Walk reading on OpenBSD source file every day. That has been a couple of shows in the past. And Alan mentioned that starting with some of the newer and easier source files would ease a reader into the process. As two people with experience of the FreeBSD source, where would you suggest a new reader with little C experience could start? As always, thank you both for your hard work and dedication. I love listening and look forward to the show every week." Thank you, Ben.
Mostly the more modern utilities. Some of the older ones just have really old C style and so on. Procstat is definitely nice and clean. It got a little muddied up, but it's nice and clean. It kind of depends what your area of interest is. Like, ideally, you'd want to read code that's kind of in the same area where you want to work. Like, another option is, pick your favorite two utilities and try them first. But FS type, Procstat, and likely anything that was added recently are definitely good examples.
So what I do each morning as part of my morning routine, I guess, I start reading the messages that have been committed basically to the source tree while I was asleep. And that's been nicely collected on the SVN-source-all mailing list. And there you can see what kind of changes people made in patch form. And you only see the differences or the diffs itself. But if there's something interesting that might interest you, then you could dig into it further by looking at the whole file and then see, that's why they made those changes. And, that's interesting, why this source file is changed that way. Or that's what this source file actually does or is integrated into a whole bigger utility. And that should give you after a couple of weeks, should give you a better overview, not only who is working on which source files normally, but also what changes are being done currently and what people are working on, or what kind of bug fixes there are. The bug tracker, FreeBSD's Bugzilla, could also be a good source because people also attach patches to it. And if you find something there that applies or is something that you are interested in, you could use that and start from there.
Yeah, I'm trying to think of other good examples.
For reading?
Mostly just try to avoid the utilities from the 80s if you can. They'll scare you away when you don't need to be.
Yeah, start small and then it gets more complicated by itself usually.
Yeah, but if you have a specific area of interest, I would look at those tools because they're nice. All the geom stuff is very nice if you want to get into although a lot of that's a little bit more kernel module stuff, although there's the user interface stuff to it, but there's not very much interesting in there because it's fairly straightforward, right? Set up, plumb it into the kernel module.
That's actually the next step, not just reading the code, but writing some code of your own. And there are a couple of examples in the geom layer for a very simple geom section or a small geom module that you can write to get some experience, or write your first kernel module. Could also be a small hello world thing that just echoes that on the screen when it's been loaded. If you're interested in that, then there are some examples on the web as well.
Yep.
Okay, I hope we gave you some pointers and interesting starting points. Next up is Jay with ZFS and speed. He writes, "Hi Alan and Benedict, I'm sort of a newcomer to BSD, that's okay, and I was trying to set up a ZFS pool on my Dell R610 server running FreeBSD 11. The drives are connected via SATA to a SASPERC 6i backplane," oh, I know those, "and I need to create a pool of some sort, and I need a pool of some sort that combines them all with minimal loss of storage capacity. I've tried striping them all with RAID 0, and I've also tried creating partitions. I cannot get the pool to the speeds that I expected when striping or even in RAID Z. I consistently max out at 60 megabytes per second, even though I know the drives are much more capable than that. The single SSD that I have installed BSD onto is capable of 800 till 110 megabytes per second, roughly. And when I DD...
80, not 800.
Oh, 80, yeah. Yeah, right. That would be bad. So when he DDs def 0 to def null, he gets around 200 megabytes per second speed. So he knows
that part confuses me right there. If you're DDing just dev 0 to dev null, that'll be memory only, and you should be seeing many, many gigabytes per second.
Yeah, that doesn't even touch the disk.
Yeah. So a couple of things here. I'm guessing because all of these are SSDs, it seems. You want to make sure your record size is correct, or your A shift. So when you're creating this pool, if you're creating 512 byte blocks and the SSD is using 4K blocks, it will mean that every time you want to write to the disk, you read 4K, modify 512 of it, write all 4K, and then read it back, modify the second 512, write all 4K, read it back, modify the third 512, write it, and that's going to be killing your performance. So make sure you're setting the sysctl vfs.zfs.min_auto_a shift to 12 before you create the pool, and see if that solves most of it. The other problem is further down when you show creating the pool, I see that you have some mismatch sized drives. In particular, your DA2 is 500 gigs, whereas your DA1 is like 120. You created the pool with one partition from DA1, 4 partitions from DA2, 1 from DA3, 1 from DA4, and 2 from DA5. Meaning that every time you want to write, ZFS is going to break that write up into, 1, 2, 3, 4, 5, 6, 7, 8, 9 chunks, and then write 4 of those chunks to the same disk. So everything, the maximum throughput you're going to get is 1/4 of the maximum speed of that biggest drive, which might not be the fastest drive. So while you get more storage that way, it's probably not what you want to do.
Yeah, it's killing the performance.
Yeah, because you're going to have to wait until the write finishes on all 4 of those parts of the one drive, and so you're really going to hamper your performance. I would, unless you really need the space, I would avoid doing that if you can, and just use the 112 gigs of each drive. And it seems like you've just kind of cobbled together a bunch of old SSDs. But yes, you should definitely be getting better performance than you are seeing. But the biggest things to look at are, while writing to the drives, run gstat and see what the actual performance going to the disks is, and look in particular at the milliseconds per read and write. And if those are very high, then the disk is what's causing the slowdown. You also want to look at the queue depths and see, how many commands do you have queued up waiting for the disk versus when you don't. And if, to help determine if it's ZFS not giving enough work to the disks or what. But I'm guessing your main problem there is the write amplification from the block sizes. So in your gpart command there, I would add the switch -a 4K to align that to 4 kilobytes, and set your ZFS min auto A shift to 12, and that probably will solve most of your problems.
Yeah, isn't it also with SSDs?
What's that?
That with SSDs, don't you also need to decrease the 30-second flush interval a little bit?
The default flush interval is 5 seconds.
Oh, 5 seconds, yeah. For SSDs,
so no, you don't need to change that.
Oh, you don't? Okay.
The other one you might look at is when you run gstat, there's an extra flag, I think it's -D, to show deletes per second, and make sure that your SSD isn't being bogged down by the trim commands. Those ones can be really interesting in your benchmarks, because the way it works is it waits a number of transaction groups before it trims the data, so that if that data gets overwritten immediately, it doesn't trim it and then overwrite it. If it's just going to get overwritten, you don't need to trim it. So if you do a benchmark using like a benchmarking tool, you'll see really high speeds until you get to the point where the trims from the first bit of the benchmark start happening, and your speed will be up, and then it'll drop, and then you'll notice that. But yes, I think your main problem is probably the write amplification from not having the correct alignments on the partition and on the axes to the device. So setting your min auto A shift to 12 and adding the -A 4K flag to your gpart command so that it aligns it should solve most of your problems. And the other one would be, I would avoid using multiple partitions off the same disk, because you're going to end up waiting on that disk in that case. Right? If you give that disk 4 times as much work as the other disk, and it's not that much faster, it's going to end up being the bottleneck.
Yeah, that's probably the reason why. Yeah, definitely try that out, and hopefully your performance will be better. Next up is Patrick, who we've interviewed a couple of weeks before about PortalFS. He writes, "Hi guys, when you covered brokering binds a couple of weeks ago, I immediately thought PortalFS. Of course, when I got to my laptop, I typed man-k PortalFS, only to find nothing appropriate. Seems like PortalFS was removed from FreeBSD in 2013, like so many other great ideas from 4.4 BSD. I actually don't remember that. It's in the specialty file systems from Michael Lucas' book.
Oh, is it? Okay.
I'm not sure how big the mention is, but it's been used there, I think. I need to look it up. But yeah, there was some reason why it was...
Go back to an old enough version of FreeBSD, if I can find the man page.
I think it was removed because it wasn't MP safe. Something like that, because we moved other file systems like Coda and other things. I'm not sure, but
although I'm not finding a man page going back to FreeBSD 4.
Yeah. And it's always the problem if there's a file system or a specific utility not being used and it's just gathering dust and isn't multiprocessor capable or does have other warts and no one will fix them, then we'll at one point have to figure out whether we should axe it completely or whether it's appropriate to find someone to update it and rewrite it at some point.
Oh, hold on. I found some more information here. Okay. Portal FS. Okay. So, Portal FS. The utility attaches an instance of the portal daemon to the global file system namespace. The conventional mount point is /p. The portal daemon provides an open service. Objects open under the portal mount point are dynamically created by the portal daemon according to rules specified in the name configuration file. Using this mechanism allows descriptors such as sockets to be made available in the file system namespace.
Okay.
Yes, this does sound a lot like what we were talking about. The portal daemon works by being passed the full path name of an object being opened. The daemon creates an appropriate descriptor according to the rules of the configuration file, and then passes the descriptor back to the calling process as a result of the open system call. This indeed sounds exactly like what they were talking about. It includes the implementations fs, pipe, TCP, and TCP listen. So yes, this sounds like exactly what they were talking about. If somebody was that interested, it might be a good starting point to go back to the latest version of this that existed and bring it forward.
Yeah. Or there's something in ports maybe that does this, but since it's a file system, it's probably difficult to have it on that level, just in user space.
There's a reference here to a UNIX paper from 1995 about portals in 4.4 BSD if one wanted to read the bits about this.
Okay.
Thank you for pointing that out to us. I didn't know that had existed before.
Yeah, it's been a while since it's been around, and I guess many people didn't.
Yeah, I didn't. I think it says it was removed in 2013, so it's not as old as, wasn't removed as long ago as I thought.
Oh, well, you never know. Okay, good addition to a previous show. And last but not least is Sir Lead Name with a ZFS pool question that might tie into Jay's question about ZFS and speed, because he's asking us or writing us, hey boys, I ordered today 3 new 8 terabyte disks for my new ZFS pool. So my question is, are there any other parameters I should set for better performance? It's mostly movie, picture, and music data. So he starts with the min auto AShift equals 12. That should give you the 4K sectors. Then zpool create with the option A-time off, the option UTF-8 only on, normalization form D, that's not familiar for me at least, ACL inherit pass-through, and compression, of course, LZ4, and then creates RAID Z pool called tank, very original, and gives them the 3 drives. And then he explains a little bit why he does these options. So A-time equals off, that's pretty much a no-brainer because he doesn't care about access time on the files and it should be faster. Yeah, UTF-8 only...
Just for a second about the A-time one. The other reason why you normally want that off on ZFS is if you have a snapshot, every time you update the A-time, that's going to be new data that has to be written to the disk because the snapshot has the old A-time. So if you take snapshots every 30 minutes on your laptop or whatever, and you have the A-time property on, every time you access a file, it's going to be writing new data that's going to be different than the snapshot. And it basically causes your snapshots to keep growing and taking up more space over time. Whereas normally you don't care about the time the file was last accessed, just modified. You can disable that and end up saving a lot of space and a lot of excess writes to your pool for no reason.
Right. Good. Okay. Next up is UTF-8 only equals on and normalization equals form D because I have files with umlauts, the Ä and Üs in German, for example, and other strange characters. So what's this normalization form D? I have not used this much.
It's just how it deals with weird characters.
Okay.
I've never used it.
Yeah, it's for any special encodings and characters. And ACL inherit pass-through is relatively easy. It's also mentioned in the book, or the books about ZFS you wrote, and together with Michael Lucas. I think it's needed for some Samba stuff he does. And compression LZ4 is, since set standard is not in a release yet. Oh, see? There's always some pressure.
So a couple things. If you create a data set that you're going to store things like media files, like movies and pictures and music, they probably don't need compression. Now, LZ4 is fast enough you don't have to worry about it, but with Z standard, it uses enough CPU, you're probably going to want to specifically turn it off in a data set you create just for movies. So the things I would suggest, firstly, I see you using the entire disk. That's okay, but if you need to boot off this pool as well, you're going to want partitions. Otherwise, you can't put a boot sector in there. But if it's just, if you're booting off SSDs or USB or something and just having this pool, then that's fine. Yes. Some of my recommendations are data sets. You want lots of data sets. Well, maybe not lots, but some. In general, my rule is I try to keep the data sets to a manageable size where I can replicate them in a decent amount of time. So I try to keep each data set under like half a terabyte. So for movies, that might mean breaking them up by year or genre or something to try to have slightly more manageable chunks. So if you have to replicate them around in the future, it's a little easier. But also, you definitely want to break up stuff based on what you're going to do with it, right? Maybe definitely movies, pictures, and music should all be separate data sets so you can have different settings for them. And also, if you use BitTorrent to download things like, say, FreeBSD ISOs or whatever, creating a separate data set for that, because BitTorrent uses a smaller block size, and if you can set the record size of that data set to 16K instead of the default 128, it will improve the performance of your BitTorrents while they're downloading, and then when they're done, you move them to the movies directory or whatever, and that. So for performance, generally what you have is here is fine. Even when Z standard comes out, you're not going to want to put Z standard equals on, or compress equals Z standard for your movies, because it'll just waste CPU time. But for the movies or any data set where you have files that are generally quite large, like more than tens of megabytes probably, if you, on that particular data set, do ZFS set record size equals 1 meg or 1 M, it's not going to improve performance all that much, a little bit, but it will improve space efficiency quite a bit. So doing 1 megabyte blocks for big files like movies and even music, probably, you end up writing a lot less metadata, which can improve performance, and writing in bigger chunks is a lot faster on spinning disks. So in my work, I've found that using 1 meg blocks, get the stats here.
Speaking of metadata, can't you also just do metadata settings on ZFS?
There's one, but you really only want to touch that one for databases. So with the 1 megabyte blocks, I'm currently... Where's this at? So I have 71.2 terabytes of data. With 128K blocks, that would have taken 77.4 terabytes of space. So basically, by writing 1 meg blocks instead of 128K blocks, it means instead of writing 8 blocks of data with 8 blocks of metadata, plus the metadata is multiple copies, so it's actually more than that, I write 1 big block with 1 set of metadata and maybe the redundant copies. So it's like 7 times less overhead. So I've actually managed to save 6 terabytes of space on 70-ish terabytes of data.
That's a lot, yeah, when it comes to that.
Yeah, so for data sets where you're going to store big files, when you create the data set with ZFS create, just -O record size equals 1 meg will increase the space efficiency, which will slightly improve performance and so on. Other than that, what you have there should probably do just fine.
Didn't the ZFS... Didn't the developers also wanted to push that beyond 1 megabyte?
So there's a sysctl that sets the limit, and it can go up to 8, I think, on FreeBSD, and eventually the on-disk format supports up to 16 megabytes as the maximum record size. I don't know that I would recommend that yet, but 1 meg's a big win, and if you have big files, it's fine. It's not going to waste huge amounts of space if you set that on a data set that's got smaller files, but it does mean that if you modify part of a file, you're going to have to read the whole megabyte in, modify it, and write that whole megabyte out. So probably a really silly thing to do on a database or a directory full of small files. But, for movies where you probably write it to the disk once and then never modify it ever again, it makes perfect sense.
Yeah, long-term storage.
Yeah, maybe even for pictures, if your pictures are 2, 3, 4 megabytes all the time, the larger data set is probably fine.
Yeah. Cool.
This raises a really good question from the chat room. If you created a data set and it had the default 128K, but you want to move to 1 meg, that's slightly more complicated. So if you change the setting, it means any newly written data will be 1 meg, but it's not going to change any of the existing data. And the way ZFS replication works, it doesn't actually solve this one for you because it doesn't reblock the data. To be more efficient, it writes the data in the same way it was when it was originally coming in. So you would actually have to create a new data set. If you want to convert data from 128K blocks to 1 meg blocks, you need to create a new data set with the 1 meg setting and then copy the files or move the files over. And then once it's done, you can delete the old data set.
Okay, so ZFS send and receive won't help you there?
No, because it's going to keep the blocks in already the same size. If you are going to replicate, though, ZFS send will break it down back to 128K blocks to be compatible with older pools by default. You must use the capital L switch with ZFS send to say that you want your send stream to include the large blocks and not break them down.
That's good to know.
But there's no way that I know of currently to force it in the other direction to do a ZFS send and have it convert them to 1 meg blocks. It might be something we could look into.
Yeah, but for there's a workaround for it, and people can use that.
Yeah. So currently, you did use rsync or copy or whatever, and just copy the data manually to a new data set with a larger record size, and it will be written with the new record size.
Cool. Good to know. And that should give you the performance you expect from a ZFS pool.
Yes. I would expect, especially for video files and so on, where you're nice, big, fat, juicy files on spinning disks, you should be able to get quite good performance from this. I would expect 2, 3 plus 100 megabytes per second reads and writes of video files to this pool.
Oh, yeah. And the more video files you collect, as you can imagine, the more space savings you might have, like you did with your pool.
Yes,
or your data.
That was a relatively large pool with 36 6 terabyte disks, but yes.
Yeah, in the long run, I mean, people keep these pools around forever, basically, because they can upgrade them easily. Yeah, so that's an option people should set right at the beginning, and then don't worry about it any further. Just store files on it, and then see the benefits after a couple of years, months, whatever. All right, that's the last question for this week, and we're at the end of the show, and yeah, that's pretty much all we have.
Is that we would like you to write in interview questions. We're going to be doing the audience interviewing Benedict and myself, and so we need questions that you want us to answer. So write in to feedback@bsdnow.tv with the subject viewer interview question, and give us the questions you'd like us to answer. What do you've always wanted to ask Benedict and I? And we will compile those together and shortly get around to doing an episode where the interview guest is ourselves and answer those questions for you. Because of some upcoming travel we got BSD Cam, VBSD Con, and EuroBSD Con all coming kind of rapid fire. We're recording schedule is a little all over the place, and so we could really use that to help fill in the content, because we're having to record early a lot of these episodes, and so we're kind of running out of news that's happening. Coming up with 2 shows in 1 week is not so bad. Doing that 3 weeks in a row is awfully difficult.
Yeah, but it's we get a lot of stuff being sent, and people should keep that up. And everything that you might find are BSD-related stories and comments, questions you might have, send it to feedback@bsdnow.tv. Yeah, that's pretty much it for this week. See you next time, and enjoy your favorite BSD in the meantime.
Yes, see you next week.